Hello everybody, my name is Ahmad, and today as my first video going to talk about a really good resource that I found earlier, which can be really useful if you are preparing for a technical interview, especially if it's involved algorithms and data structures. Most of the companies, especially the bigger ones, when you go to a technical interview, they will ask questions about algorithms and data structures. And I know right now the job market is really rough. Um, I myself was looking and job hunting a few months ago, and it was really challenging. And I know friends who are still looking, and I know how important is that to be prepared for those sessions. And I hope this resource can be useful for that. One good thing about this is that it's completely open source, so you can basically run it in your local machine and try and practice whenever you want. And it cover almost most of the famous algorithms and data structures questions that you might see in any interview. And we will walk through it in a second, and I will show you uh, the platform, and also we will go through how you can install this locally and how you can run it in your local machine. But the other good thing about it is that it does have unit tests for the challenge, so you can try to solve your challenge and then run the unit test against it to make sure your solution is correct and it will pass the test. There is also a solution for each challenge. So if you try to solve it and you face some problems, you needed some help, you can always switch to the solution. And the other good thing about it is that it's running on Jupyter notebook, which is a really cool and simple computing platform that you can use. We will go through it in a second. Before that, let me give you a quick tour about like how complete is this list of algorithms. That you can see does almost have everything: array string, graph trees, and each one of them have a bunch of famous questions. It categorized really well. Um, and Yeah, so let's go through like one of them, for example, 3DFS. And as I mentioned, it does have a challenge and a solution. So you first probably want to try yourself to solve it. And as you can see, it will simulate the exact same thing that you will see in a job interview, especially if it's a algorithm or data structure question. Usually it's same as here. You will see the problem, the constraints, the test cases, and then you need to implement it. Once you implement your solution, there is a unit test for that, and you need to run it against it and make sure your solution works. And as I mentioned, if you need help, there is a solution for that, and you can check the solution. And there will be one solution for that challenge. And as I mentioned, working with Jupyter is super simple. How you can run it is that you need to go to each section, and the only important part is that you need to run them step by step. Like you should go to number 1 first, run it, and then go to number 2, run it, and you shouldn't just like jump to number 4, for example, and then number 3, and then you can basically run the unit test and see if it's passed. So yeah, this is the platform, and I will show you how you can run it locally. So I already run it. I will close this down and let's try from scratch. As I mentioned, it uses Jupyter. If you don't have Jupyter installed, you can install it. I will share all the links and comments in the comments. Also, I wrote a blog post about this. I will share this one as well. It does have everything here as well, so you can try and check that out as well. So let's install. I already have it. I will run it again. That's fine. And once it's installed, you need to clone a repository, which basically hosts all these challenges. And you can find the repository link comments. Then you need to just go to the directory and finally run the notebook. When you do that, it will run on localhost 8888 port, And here you go, you have this up and running. So I hope this can be useful. Try to be prepared and be strong. And I hope you nail your next interview.